Hello friends, in this tutorial we will learn how to build a low-cost and flexible data logging system using Arduino and Python 3. The system is capable of monitoring 4 analog temperature sensors and logging the data from them to a CSV file on the PC. This tutorial will help you to gain a deeper understanding of the data acquisition process and in the future will help you to design a more complex one. So on the right side image, you can see our data acquisition system. It consists of 4 analog temperature sensors and a analog front end comprising of LM324 Opamp. Then an Arduino UNO is used, which is used to digitize the analog signals and is sent to the PC. Now you can either use LM35 temperature sensors or other analog temperature sensors like thermistor. Now you can also use this device to monitor other analog parameters also. So the whole thing is based on Arduino UNO, and if you want you can also use the Arduino Mega if you require more channels. Now we will have a Python 3 script which will be running on the PC side, and the script will communicate with the Arduino, this one, and then we'll get the data from the Arduino and log into a text file. The data is stored in a comma separated variable in a text file, which has a file extension of .csv. This is the format. Now the PC side system is written in Python 3 and is cross-platform. You can use it on Windows and Linux. You can also use it on Raspberry Pi if you want to. You'll have to connect the Arduino UNO to the Raspberry Pi's USB port. The system is quite cheap and flexible, and the tutorial follows a do-it-for ethos, and we will explain almost all the steps which are involved in building the hardware and software of the data acquisition system. Now on the left side of the screen, here you can see the Python code running on a Windows 10 PC. It is running on the command line, and on the right hand side you can see the comma separated variable which is opened in a notepad or a text editor. Now I'll come here. The system is showing the type of operating system here and the Python implementation here. Now the system will ask to enter the serial port number. Here my serial port number is COM4. This is the same serial port number to which your Arduino is connected. Now we will be using the baud rate of 9600, which is the standard baud rate. You can change it in the code. After this, the Python program will create a text file which will be having the following format. It will start with the text ARD, then it will display the date at which it is created, and second, the time at which it is created. And it will be a text file with a .csv extension, and we will have a logging interval of 1 second. That means that the script will check the Arduino for data every 1 second. Now after the Arduino is triggered, it will start sending the information back to the PC, which is displayed on the command line like this. At the same time, it is also logged into this particular text file. Now the logging system will have a number, that is the number of the log. Second, there will be a date, third, time, and the data from the 4 analog temperature sensor channels. Here we'll be using temperature sensor, so all the data is in degrees Celsius, 35.44, 34.26, 34, 35.06, like that. Now the system will keep on querying the Arduino until you press the Ctrl+C combination in the keyboard. Now on receiving Ctrl+C key press, the script will terminate and will save the file in the hard disk. Then you can open it and check it. You can also use Excel or other plotting program to display the data in a graphical format. Or you can also use it to do other processing like matplotlib or some other numpy or scipy like that. This shows our hardware setup. We have an LM35. We have 4 LM35 temperature sensors, which are these black colored sensors. Now these are 3-terminal LM35 temperature sensors that are enclosed in a heat shrink wrapping and is connected to the amplifier board. This is the amplifier board, which has 4 input channels. So the low voltage coming from the temperature sensor is amplified and is then sent to, you can get the output here. And then it is sent to the analog input of the Arduino UNO. The pin numbers are A0 to A3. 4 analog temperature sensor, analog channels. And the Arduino process the signals and it will generate various temperature, which are then sent to the PC using the USB port. So I have completed the setup. Now I have connected the Arduino to the PC. Here we are using a Windows 10 PC and it is connected to the PC through the USB port like this. And we have the script which is about to run right now. So if I give the port number, it will start logging the data. I'll give a proper screenshot, screen capture later. Just I want to show it right now. So it will start logging right now. So you can see the script logging from here. And you can see that two sensors are logging the temperature of the PCA heat fan output, and the other one is logging the ambient temperature. In the future, we will create some more videos like this one. I am planning on creating a video that will teach you how to do a data logging to an SQLite 3 database. Here we will discuss the requirements for building the Python data logging system. On the hardware side, you require an Arduino UNO, which is commonly available in the market. You can buy it from anywhere, or you can use a Arduino Mega is also possible, but our code is currently written for the Arduino UNO, but you can easily adapt it for the Arduino Mega also. Now we require a 4-channel LM324 Opamp amplifier. That will be this one. And we have already covered the design and implementation of LM324 Opamp amplifier in our video. You can check our YouTube channel. I will put a link in the description. In that particular video, you will show how it is designed, what calculations are made, and how you can assemble it. You can also buy it from our store. The link to the amplifier board is available in the description. And the other thing we require is an LM35 temperature sensor, which will generate an equivalent analog voltage depending upon the temperature. For example, for every degree Celsius, it will generate 10 millivolt. Now you can create and you can build the sensor by connecting it to a 3-wire cable and then wrapping it in heat shrink. I have also done a video on that one. You can check that one. And you may require a PC, Windows or Linux PC, for storing the result and for running the Python code. Now on the software side, we will require an Arduino IDE for compiling the code for the hardware section. Here Arduino, so you should have a basic understanding of the code. And secondly, we require a Python interpreter like CPython. Then you also require PySerial library, which has to be installed on the interpreter. I will tell you how to do that. And also you should be familiar with Python serial port programming. Both those things we have already done the video. You can check it out from our YouTube channel. Now we also have a website which you can check it if you like the tutorial in a textual format. You can also find the links to our code and other resources on our website. This is the website. And you can also check out the GitHub for the code. We have the code here. The Python code is here and the Arduino side code is here. Now you can also check out our Linux serial port programming and the Python serial port programming tutorials, which are essential for this one. So do check it out. And if you like our content, do give it a like. And if you like to subscribe also. We also have a Twitter handle here. All the links are in the description. Now this is the block diagram of the Arduino data acquisition system. Now we have 4 LM35 sensors, which are this one, represented by these pink octagons, and they are all connected to the 4-channel LM35 signal amplifier. The LM35 will be generating millivolt signals. For example, in the case of a room temperature, 30 degrees Celsius, it will generate 300 millivolt. Now they are amplified by the LM35 and a higher voltage is given to the analog input of the Arduino. We will connect the pin numbers AN1 to A0 and AN4 to A3 of Arduino. And inside the Arduino, the microcontroller will read the analog signals and convert it to digital equivalents. Then it will calculate the temperature and the data is sent through the USB to the PC. Now this is the whole thing is the PC side section. We will have the Python communicating with the COM port or the serial port using the PySerial library. Then it will read the serial data and write that data into a comma separated variable. Now this will go on for some time continuously until interrupted by a Control plus C combination. So whenever this Control plus C is pressed, the operating system will generate a signal or an interrupt called SIGINT, which will terminate the program. Now I'll explain how to do that in the later sections. This is the block diagram of our analog front end. This is used to amplify the signals. So we have the LM324 Opamp here. It is a 4-channel Opamp and it will take the LM35 signals, which are in the millivolt range, and it will be amplified to voltage range. So the gain is around 3.4. So millivolt into 3.4 times. The output will be available here. So it can be interfaced with the 5-volt logic of the Arduino. Now you can also have a voltage divider here, which if you want, you can use it to interface with 3-volt tolerant chips, for example, MSP430. The power can be provided here, plus 5 volt and ground. Now this board is available from our website. If you like it, you can buy it from our site, or this is also available as a soldering kit, which you can solder and learn about it. This is a 4-channel Opamp. Now I'm going to show only one of them. Here we will give the input from the LM35, which will be around 0.28 volt or 280 millivolt to the input of one of the Opamps inside the LM324 chip. Now we are setting the gain at 3.7 and we will be using the resistor R feedback resistor is equal to 27K and the other one is 10K. So the gain will be around 3.7 and that will be multiplied by the 0.28 volt into this gain, which will result in 1.03 volt. Now, as you can see that these are theoretical values. Now, in the actual case, we won't be having precision resistors. I am just using 5% resistors. I mean resistors with 5% tolerance. Now the output of the output will be around 1.03 volt. This one. That output is available from the board, and we also are using a voltage divider, which we can use if you want to interface with 3.3 volt tolerant chips like MSP430 or STM32. Now we have calculated the gain as 3.7. Now you have to understand that I'm using 5% tolerant resistors. So the value will not be exactly 27K or 10K. So the real gain may be different. So I have manually checked the resistance of the feedback resistor 27K and the other resistor 10K. And there has been some discrepancies. So I have included that in the calculation. So the real gain is around 3.4 volt, sorry, 3.4. There is no parameter. So in the calculations, I will be using the gain equal to 3.4 so that we will get a more accurate result. Now here we will explain the basic protocol for communication between the Arduino and PC using the serial port. Now we have the Arduino UNO here. This one. I have omitted the analog circuits. It will be somewhere here like this. The temperature will come from here and will be connected to the A0 to A3 pins of the Arduino. Now we have a PC here. The PC may be running Windows or Linux, and we have a Python script running on it. Make sure that the PySerial is installed. So when you run the program, the Python script will send the character $, this one, towards the Arduino. We will send the $ in ASCII format, and the Arduino UNO will receive it. On receiving the $ character, the Arduino UNO will read the analog values on its analog pin A0 to A3. Then it will convert it to temperatures. For example, 20.2 degrees Celsius or 30.5, depending upon the temperature at different analog input. Now then it will send the characters back to the PC using the serial port or the USB cable connecting the Arduino UNO. Now the way in which the encoding in which the temperature is sent is something like this. We have the first temperature value in characters, ASCII characters, and then we will send a dash, then the next temperature, dash, like that. And in the end, we will send a new line character. So if you see the output from the Arduino UNO using a serial monitor, you will see something like that. 20.2 hyphen 30.5 hyphen 40.6 hyphen 45.6 and a new line character which will not be displayed. So we are using the Python serial monitor to access these values and then log into our text file. Now the reason why we are sending the new line character or the \n is that we are using readline function in the Python script. So to terminate the readline function, the method has to receive a new line function. So if you don't send it from there, it will keep on reading it. Here you can see the basic hardware that is required for building our Python data logging system. Here we have 4 analog temperature sensors. This one, the one in black, it consists of LM35 temperature sensors, which will generate voltage corresponding to the ambient temperature. Now we have an amplifier board, green board here, that is used for amplifying the signals from the LM35. Those signals will be given to the Arduino UNO here, and the Arduino's ADC will convert the analog signal to the digital signal, and the digital signal will be transmitted to the PC using the USB port of the Arduino. A Python program that will be running on the PC side will take those digital values and will log into a text file. Now we have 4 channels and we have 4 temperature sensors like this one. And this is the analog amplifier board. This is just a Opamp amplifier, a 4-channel Opamp amplifier based on LM324. And this board can be used for amplifying any analog signals. For example, if you want to interface a thermistor or other analog signals, you can use this board. The amplification of the board is around 3.2. So any signal will be amplified 3.2 times. And the Arduino we are using here is any Arduino you can use. Here we will be using the 4 of the analog channels for converting the analog signals to the digital signals. Now if you want, you can also, if you want more analog channels, you can use an Arduino Mega or something like that. The code is almost similar, and we will be using some wires for connecting the amplifier board to the Arduino. Now if you're interested in our Arduino board, you can buy it from our website. It is available in the form of a kit or a finished product. The link is in the description. Do check it out. Now we are going to connect the temperature sensor to the amplifier board. Here you can see that we have 4 inputs, which are J3, J2, J1 and J10. This one, this side. Now you can see there is a 5 volt power supply, then AN1, AN2, AN3 and ground. AN1, AN2, AN3 and AN4 are used for connecting the input of the LM35. These are the input for the Opamp, and the amplified output is available right here. And you have to connect the amplified output to the Arduino. Now I have created these probes of LM35. I have already done a video on how to make this one. So if you're interested, you can check it out. The links are in the description. Now we will connect the probe, this one, to the input of the LM324 Opamp. So the red one is the plus 5 volt and the black one is the input. So we'll connect it like this. Now the sensor is connected to the amplifier board. If you power this board, we can get the amplified output from here. AN1 is corresponding to AN1. So we'll connect the other 4 also. Now all 4 sensors are connected to the board. Now we have to connect the amplified output. That would be this side. And you have to connect it to the Arduino. Now we'll connect the output to the analog input. Here it will be A0, A1, A2 and A3. So you can take a wire like this and you can connect it to A1 here, which will give out the amplified output, the analog output, and then you can connect it to the A0 of the Arduino. Like this. You can connect the rest of the other one too. All 4 of the lines are connected now. Now we will be powering the amplifier board from the Arduino. So the power supply section for the amplifier board is right here, the power pin, and you can power it up. You have to provide power up to 5 volt. For that we will be using this burger. We'll connect it here. We'll take it from the Arduino. So it will be V in. This is V in, ground, and +5. Now you have to connect the ground. Now the system is connected. Now we will connect it to the computer. Now we are going to run the code as well as the hardware. So we'll first download the code from our GitHub repo. You can also find the code from our website. So go to the source code section here. So you can either go to the GitHub or you can download as a zip by clicking here. So if I click here, it will come out as a zip file which you can download like this. Now also you can download it from our GitHub. So you can either fork it or download it as a zip file from here also. Like this. Click it here, it will start downloading. Now I have already downloaded it. So if you have downloaded and unpacked the code, you can find something like this. We have the Arduino side code here and the Python PC side code here. Now first we'll go for the Arduino side code. Now I have connected the Arduino to our PC. So you can go here, Tools, port is COM4. So this is the serial port to which our Arduino is connected. And now I am going to download the code into the Arduino. It will compile the sketch and it will download it. Here we will explain the code that will be running on the Arduino. Now we have the Arduino here to which the analog signals will be connected. Now the Arduino code will have two sections. One is called as the void setup, which I am not showing here, and the other one is called as the void loop, which will continuously run. So what the Arduino does is that it will check whether a $sign is received or not. This is the ASCII $sign which the PC or the Python script is sending to the Arduino. So using an if, we will be checking whether a $is received or not. Once the $is received, the code will enter here and it will call this particular function, which is called as the read analog channel, and it takes an analog pin to read as an input. So you can send the analog pin number like A0, A1, A2 as an input parameter. Once that is given, the code will go here. This is a custom function which I have wrote and is not part of the Arduino library. Now when we get it here, the code here will take 3 consecutive readings from the pin A0, and we will store those 3 consecutive readings in an array. Now once the value is stored, that value is used to calculate the average of the 3 readings. This is to reduce the noise and to get a stable reading. Now once we have got the average of the analog value on the pin A0, we will use that value to calculate the temperature. I will explain the calculation later. Now once the calculation is completed, the value, that is the temperature, in the form of a float variable is returned back and is stored on the value temp1. Next, there is another value called temp2, which will call the same function. And instead of A0, it will give the value A1. And it will come here and it will calculate the temperature at A1. And the value is given to temp2. Like that, we will go for temp3 and finally temp4. In this way, 4 analog channels are read and their temperatures are calculated. Now, once all these values there, we will then send the value to the PC using the serial.print function. We are using the print one, not print ln. Now, first it will send the value temp1 followed by a hyphen. So it will be serial.print hyphen, then serial.print temp2, then serial.print hyphen, like that up to temp4. Then we will send a \n to terminate the Python readline function on the other end. Once that is completed, the Arduino will again wait for the reception of the $item, dollar value. So this is how it works. This is the pseudo code. I will also explain the main code. Here I will explain how the analog signal is converted to digital signal using the 10-bit ADC of the Arduino. Now the Arduino is actually a Atmega 328P microcontroller which has a 10-bit ADC inside it. Now we have the LM35 sensor here which produces the millivolt signal. Here let's say the voltage is 363 millivolt or 36.3 degrees Celsius. Now we will use an Opamp. This is a single channel Opamp right now. We'll be showing only one channel of the Opamp and the gain is 3.44. Now previously we have told that the gain was 3.7. I mean the calculated gain was 3.7. But if you measure the actual resistance and then recalculate it, we get the gain to be around 3.44. That's because of the errors in precision of the resistors. We are using that 5% tolerant resistor. So we will take the gain equal to 3.44. Now the millivolt signal is multiplied by that gain and it will give you a voltage of 1.24 volt. That 1.24 volt is fed into the 10-bit ADC through the analog channel of the Atmega 328P. So here it will be connected to either A0 or A4. Now this is the ADC. So it's a 10-bit ADC. These parts are inside the Arduino. Now being 10-bit, that means that it will divide the voltage into 124 divisions. So each division will be 4.8 millivolt per division. For this particular voltage, 1.24 voltage, the ADC is producing the number 245. And I'm using the VRF equal to 5 volt, the reference voltage for the ADC. Now the ADC number is equal to 245. So I mean, it is the 245th division. So if you multiply that with this particular value, we will get the voltage. Now here we are doing the same thing. Here we are multiplying the ADC value, that is 245, with 5 divided by 1024. This particular value to get 4.8 millivolt. So here we are using 5.0 and 1024.0 because we are using float. If you use the just 5 and 1024, it won't work. There will be errors because the system will have issues converting from int and float. So I recommend you use 5.0 and 1024.0. So we'll get the value equal to 1.1 volt. This one. Now this is the value, I mean the voltage after the gain. So you have to divide the value, that is 1.19 volt divided by 3.44, this value. So we could get the voltage. Here it is 363 millivolt or 0.363 volt. Now we are getting that particular volt here. We'll get 0.3477. Now you have to multiply with 100 to get the temperature. Now it is showing the temperature as 34.77 degrees Celsius. That is due to the error in calculation, I mean the error in the system. Now there is a small error in the ADC and a small error in the Opamp. All these things add up, and we have an error of around 1.6 degrees Celsius from the value we are getting out of the ADC and the actual value. Now you can change that by using precision amplifiers or by using a ADC with more bits. But here we'll be using only 10 bit, and so we will get a temperature of 34.7 degrees Celsius here. This is the error. So I just wanted to tell about the error also. So if you want to minimize it, use a better amplifier here and a more bits for the ADC. And now this is the actual code that will be running on the Arduino. Here I have declared 4 integer values which are used to store the analog pin numbers. Here analog pin underscore A1 correspond to A0. So we have all these things are declared outside both void and void loop. So this is like global variables. So in this first thing we do is we put the setup where we configure the UART to transmit at 9600 bits per second. So after which we'll go to the loop 1. Here I am declaring the first received byte equal to 0. Then we are using a float variable to declare 4 variables, which are temp1, temp2, temp3 and temp4, which are used to store the temperature of the 4 analog channels. All these are float variables, so we have to use the 0.0. If you just put 0, this won't work because we are using float variables, so we have to use 0.0. Now first we will check whether serial is available. So if we have received something, we will store that value to received byte using the serial.read1. And we will check it here whether the received byte is dollar or not. If it is not dollar, we will go here and we will print invalid and send a message. Use dollar to start conversation back to the PC. Now let's say if we receive the byte equal to dollar, we will go to inside the if loop to this particular line where we will call the read analog channel function, and we will give the corresponding analog pin. So we want to send A0. So we will call the analog pin underscore AN1. We have earlier declared that on top. Here we have declared that one. So this will call this particular function. So analog pin A0 will come here, and I will explain the variables here. We have an array of float called as sensor value. It has 3 elements for storing 3 consecutive readings. And we have an average sensor value, which is to store the average sensor value of all these 3 readings. Then we have a float temperature, which will send back to our loop. So first we will do is that we will use a for loop here, which is used to take 3 readings from the same pin. So here we will take 3 readings, and inside the array, for example, inside array position 0, we will store the first value from the pin A0. Then we will read the pin again and store the second value in 1 and the third value in the position 2. So here we are taking the value from the same pin again and again 3 times and storing it in this particular array. And then we will add all these 3 readings and divide by 3 to get an average sensor value. This is to minimize the error or to get the to minimize the sudden changes in temperature. You also have to put a small delay here. Now once the average sensor value is got, we will use this particular line to convert it into the temperature. Then earlier I have explained that we have to divide by 3.44 because that's the gain. We are multiplying it in the analog sensor. Now here we have to divide it to get the actual value. So we'll multiply it with 100 to get the value in degrees Celsius, and then we will return it back to temperature 1. So that value will be stored in this one. Same thing happens for these three variables also, and all the information is stored in these four variables. Then we will use the serial.print temp1. It will send the first variable followed by this dash, temp2 followed by dash, like that. After which we will send a \n only. Then the system will wait for the another $. This is how the Arduino code works. Now we will go to the Python section. You can find all the codes inside this one. So we have three Python files. First one is called as the Python Arduino symbol query. Other one is called as symbol logger. And the last one, the top one is called as the CSV Logger. Now the first one will not log anything. It will just display the data on the command line without logging. The other one will just log it. And the third one will use a signal handler like Ctrl+C to log the data and to exit gracefully. So I will explain all three of them. This is just for opening the command line. Also, you need to have a Python interpreter installed, and you should be able to have the PySerial library installed inside the interpreter also. So we'll start the command line. Now we are going to run the Python program. Now for running the Python script, you need to have a Python interpreter installed. I'm using CPython, and you also need to have a PySerial library installed. So I will show you the code. The code we are going to run is this particular one, the Python Arduino symbol query.py. Now this code will not log anything. It will just read the data that is coming from the Arduino from the PC serial port, and it will display the data on the terminal command line actually. Now if you are not familiar with Python serial port programming, you can check a video that we have already done. The link is in the description. This is the video. The video is on our YouTube channel. If you like this type of video, do subscribe and like. If there are any issues, you can make a comment in the comment section, which I will try to. Now you can check whether PySerial is installed or not by typing Python -m pip list list. So it's showing that no, PySerial is not installed. The other way is that you can simply check Python, go to the the interpreter, and type import serial. So it is showing that module not found error. So we have to install it. We will use the pip tool to install it from the website. So you need to have an internet connection. Python -m pip install PySerial enter. So it's installed PySerial, so you can check it. So this thing is installed here. Now you can check it in the interpreter also. So no issue. This is the simple query code, and here we will be opening the serial port, and here I am giving COM4. This is the COM4 in my system. In your system it will be different. This is the same COM4 in which Arduino is connected. So you have to check that. So check your number before running this code. Now there is a small time to sleep here also, because after opening the COM port, the Arduino will get reset. So it will take some time to come back online. For that, we have to give this particular one. So after that, the code will continuously send the character $, to the Arduino. The Arduino will reply the data, that is the temperature. 4 temperature values will be sent here, and we will display that on the command line. Now we are using the designated B here to specify that we are sending it as a byte. That means this will be sent as an ASCII byte. Then we wait for some time. Then we will use the readline function, because once the $ is received, the Arduino will be sending the temperature. So we will be ready to read it. So we will read it until we encounter a new line character. After which we will return that data to received string. Now the characters that are received is in the byte format. So we will use a string function to convert it to a string of UTF-8. Then we will use the split function to divide the values into separate temperature values. So here we are using, in the Arduino side, we are sending temperature hyphen. So we have to split it hyphen. So we are giving that particular character here. Then it will print all these values here. And it will sleep for 1 second, and then we will do it again and again. So we'll run it right now. So we have connected the Arduino on the other side. I will run it. You can see the temperatures. And the center one, AN3, I'm connecting to the output of my PC's fan. So you can see the temperature is slowly increasing, like 35, 36. The rest of them are actually the room temperature. Now we have reached 38 like that. This is what simple query does. It just shows that there is no logging. Now in the other one, we will log it. So we'll go back to that one. So you have to exit from here by pressing Ctrl C. Sorry, Ctrl C. Now here we'll be using the symbol logger. The symbol logger will create a file, and we will log the data into that one. Now we are going to run the Python Arduino symbol logger. This is a symbol logging program that will take data coming from the serial port and log into a text file. It will generate a unique file name using the system date and time, and can be used to log data. So I'll run this thing. Before I run it, you have to make sure that you're using the correct COM port number. So you can go inside the program and you can change it if you want to. Here you have to change the COM port number. I am using the COM4 number, which is the same COM port number as that of our Arduino. Now you also have to change the baud rate if you're using a different one. Now if I enter this program, it will start the logging system. It will create a file name using the current date and time, then it will start the logging process. Now you can terminate the logging process by pressing Ctrl C. Now I'll explain the code. First, we have to import the serial library as well as the time library. Serial is for the PySerial. Then we are going to create a unique file name using the system time and date. For that, we will use this particular function, which is a variable from time, this one. So it is time.localTime, which will get the current time. Now it will be in the time format. You have to convert that into the string format. For that formatting, we will be using the strf time, which will change the time into day, month, year, then hour, minute, and seconds. And these are separated by underscores. So it will be something like the date 20 and %B means February. Then year, hour, and minute and second. So this will be a string which will concatenate with this particular variable, text on this one. So this will create a unique file name which is used to generate a text file. For creating that text file, we will be using the open function, and we will open a file using the file name, which will be the one that we have created earlier, this particular variable. And we will open it using the W+, that means you can read and write. And we will create the file handle as CSV file. This is the file handle which we will use to do functions on the particular file. So first thing we will do is that we are creating a comma separated variable. So for that one, we have to create a header. So this is the header. First one is the number, date, time, and the analog values coming from N1 to N4. Now we will also start the log count. We will set it as 1 because we are going to log it from 1 instead of 0. Then we will open the serial port. Now we have already done a video on opening the serial port, so you can check it out from our YouTube channel. And if you have any doubts regarding the code that I have explained, you can put that in the comments. I will try to explain that. Now we will use this particular function to create a delay of 3 seconds. This is because when we are opening this serial port, the Arduino will get resetted and you have to wait some time for it to get back in. Then we will use an infinite loop to continuously query the Arduino to get the data from it. For that, we will be using this one. We will write the character $, and since we are sending the character in the ASCII format, you have to specify that it is a byte or an 8-bit. So we will wait some time. Then we will make the serial port of the PC to read. So for that, we will use the readLine function, which will terminate on when it receives a new line character that is sent by the Arduino. So once that is done, the temperature variable will be inside the received string. Now we will use this particular function to convert the byte to the string format. Then we will split that particular string along the hyphen. So the value that we are sending will be in the form of temp1 hyphen, temp2 hyphen, temp3 like that. Now if you use this particular function .split, it will split and generate a list of variables. So this will be a Python list of the temperatures. Whatever temperatures are there, they are inside this in the form of a list. Now this is the separator. The separator is we are using a comma separated variable. So we are giving it a comma. If we change it to some other variable character like a hyphen equal to or a vertical dash, you can change the separator. Here we are using only comma. Now here we are using in the first stage of the program, we try to get the local time to create a file name. Here we are using the local time to timestamp the values that we are receiving from the Arduino. So they are doing the same thing here again. This is for formatting the time so that we can print it into a file. Now here we are converting the log count, which is an integer value, to a string using the str. Then we are adding, concatenating that with the separator, which is the comma. Then log date, which is from here, the date. Then separator, log time. I have separated that log time and date are different. And separator like that. Then I told you that this one is a list. So we will be accessing the variables inside that list using this particular notation. The first value, second value, like that. And we are also joining them. And in the end, we are joining all these three into log file underscore text 3, which is then used to write into a text file. Now we will open the file name and we'll open it in the append mode so that the data is still there, because we don't want to lose the data. And we will write into the log file. We will also print that data outside so we can view it on the command line. Then this is used to change the timing duration. For example, if you want to log the data from the Arduino for every 1 second, you can put 1 here. If you want it to be 10, you can change it to 10, depending upon your needs. Then it will go back again and it will send the dollar, get the data, write it back like that. Now you can't exit from this infinite loop. So when you press Ctrl C, it will terminate it, but it won't terminate in a correct way. Some of the file handles and the other open resources will be lost. So the code will never come here. So in the next program, we will be using a signal handler to capture the signal interrupt, which is a Ctrl+C combination, and to exit from the script, the infinite loop, in a graceful manner where we close every open file and connection. So I'll do that in the next one. So I'm going to explain the main program, the main Python 3 data logging code. Now this one we will be using a signal handler to capture the Ctrl+C interrupt and then exit from that while loop, the infinite while loop, gracefully. So the code is almost similar to the one I have explained, but the main difference is that we will be using a signal handler here, and then we will use that signal handler to exit from the code. So the main variable we have to check is this one. This is just a Boolean variable. This is not the full code, it's a pseudo code. You should remember that. So in the beginning, we will make this entry equal to true. Now we will do the same thing as we have already done. We'll generate a file name using current date and time, and then create a file name. Then we will write the data, etc. Now we will be creating a signal handler right here. The one inside the red box is the signal handler. And I have already done a video on how to create a signal handler. You can find that in the video description, and it's in our YouTube channel. If there is an issue, you can write down in the comment section. I will try to explain it. So inside this, we are putting the sentry variable, and we have to make sure that it is global, and we will turn it into false. This code inside the def signal handler underscore SIGINT will only run when you send a Ctrl+C interrupt. Otherwise, this will not run. So once you have created the signal handler, you have to register the signal handler with the system. So this is what they are doing it. So you have to write it signal.signal and the name of the signal. Once the registration is complete, whenever that particular Ctrl+C SIGINT is received by the system, this code will run. Okay. So we will move to the next section. Well, we will use, instead of an infinite loop that we have previously used, first we have to open the Python serial port here. After that, we will go into the infinite loop for querying the Arduino. So instead of an infinite loop, here we will check whether sentry is true or not. Since we are setting the sentry equal to true in the beginning of the program, then the code will run. It will do the same thing. It will send the data, the $sign, and it will get the data coming from the serial port, and it will do everything that it is. So it will continuously do it again and again. Now, when we want to exit from the data logging system, you have to press the keyboard combination Ctrl+C. So when you press that Ctrl+C combination, a SIGINT interrupt will be generated. When that SIGINT is generated, the code will come here inside the signal handler. Then here it will make the sentry equal to false. Then the code will jump back and it will check again. So now sentry equal to true is wrong, and the code will move from here to here. It will exit from here and it will close all the variables right here. So I'll run the code right now, and I'll also give you how the code is written. Okay. Now we are going to run the program. So this is the code, Python Arduino CSV Logger signal handler. So we'll run it. Now, if you don't know how to use the signal handler, I have already done the video. You can check it here. It's in our YouTube channel. So that one. The other thing is that since you are using the signal handler here, it's much better to run the code in the command line. If you are running the code inside an IDE, it may cause some issues. So press enter. So this one has a little bit of more bell and whistles. Like it will display the OS full name, which is Windows 10, the version of the Python we are using. And now I have to enter the COM port. The earlier version, it is hard coded. Now I will just enter COM4. Now it is saying that the port is COM4 and the baud rate is 9600. And it's created a file like this one. And the logging interval is 1 second. Now you can exit from this loop by pressing Ctrl+C. So when you press Ctrl+C, the signal is caught and the sentry variable, which was earlier true, is changed into false. So it will come here. And the data is logged here. Same data only. The only difference is that we will be using the Ctrl+C interrupt. So I'll show you the code right now. This is the code. It is similar to the code I have shown in the previous one, the symbol logger. Here we'll be using some more. We'll be importing the signal for the signal handling library. And this is for platform. This is to show which platform the system is running. This is not important, it's just for the show. Then we will declare variables called log count, logging interval seconds, and baud rate. Now, you can change it from here. If you change it to 2, logging interval, if you change it from 1 to 10 seconds, the whole thing will change. So we are setting the sentry equal to true first here, then some other printing systems. So platform.system will show the different variables of the system, the release number, which OS, which version, those things. Same here also, it will show the Python implementation and its version. Here we will take the COM port input. we'll be using the input function to get the COM number inside, and we will convert it to upper, and that means it will just simply show the whole thing in the capital letters just for show only. Then the variable COM4 will be inside this one, which is then given to the serial port program. Then we will generate the current file name using current date and time, the same thing. Then we will create a CSV file and its header. Here we will be creating the signal. This is the signal handle function. We have to give the signal number and frame. Then here we will be turning the sender equal to false. This will only run once the signal is received. Otherwise, sender will be true. So we will register the signal. Then we will just open the serial port using the COM port number and the baud rate. Same thing here only. So the whole thing will run in a continuous infinite loop. So here they will check whether sender is true or not. So whenever sender is false, that is when you press the Ctrl C, the code will come here and that sender will turn into false. Then the control will come back to here. Then it will close the serial object and it will stop logging. So if there is any doubt, you do put it inside the comment section. And if you want, I can make videos on how to use the logged values with the matplotlib to plot it. If you are interested, do put it. And in the next video, we will try to log into a database. I hope you found our data logging videos quite informative, and I think that you may be able to use it for your personal and professional uses. Now in the future, we will be creating a Python data logging software to the SQLite 3 database. So if you are interested in learning about that, please do subscribe and like. If you have any comments, do write it in the comment box. I will try to reply with it. That's it. Thank you for listening to our tutorial. Hope you enjoyed it.